Hello everyone, welcome back to my class. So our focus for today is to learn about the three gas law, which is your Boyle's law, Charles' law and Avogadro's law. Okay, by the end of this lesson, I will also show you how we're going to derive the ideal gas equation from these three gas law. Alright, but before we continue with our tutorials, just want to let you know there are four variables that will be used continuously in this 5.1 gas, which is pressure, referring to pressure of gas, volume, referring to volume of gas as well. The third one is the temperature, and the fourth one is amount, or in simpler version, we can say that is number of mole of gas. Alright, so first, Boyle's law. Okay. This is the definition of Boyle's law, which it states that at constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the pressure of gas, okay, which means your pressure is inversely proportional with your volume. Okay, in other words, I also can say if I increase the pressure, means my volume also decrease. Okay, it works in a reverse way. Okay, if I decrease my pressure, then my volume will be increasing. That is what it means by inversely proportional. Okay, so the formula that we're going to use for Boyle's law is P1 V1 equals to P2 V2. Alright, so this is the formula that you're going to use. Okay, to use this Boyle's law formula, you don't need to make sure P and V is using the SI unit, which as we know, to use ideal gas equation later on, we need to make sure pressure is in atm, volume is in liter. But if you are using just Boyle's law, you just need to make sure if pressure 1, you are using atm, so your pressure 2 should be in atm. Okay, so the unit of pressure that is available is atm, millimeter mercury, torr, and Newton per meter square. Okay, so these are four units of pressure that you need to know. Alright, so the conversion unit between each unit of pressure, you can check on it from the list of constant that I already give to you earlier in this semester. Alright, okay, so another case, if let's say you're using your volume in milliliters for V1, that means for your V2 you also need to use your volume in milliliters. That's it. That means you just need to remember, okay, if you're using your Boyle's law, you just need to make sure the unit for both pressure and volume at 1 should be the same unit at 2. Alright, okay, before we try to use this formula, let me show you the graph that is involving in your Boyle's law. Alright, so these are the two graphs that we use in your Boyle's law. Okay, so the first graph here, okay, which shows volume is inversely proportional with pressure. Okay, and the second graph here, if we want to find the slope, okay, the slope means the gradient of the graph, we need to make sure volume is being sketched in a graph versus 1 over pressure. So volume equals to K over P, and this K referring to your slope. Okay, so you need to memorize kind of graph, what kind of graph is available in your Boyle's law. In case in the exam they ask you to show graph involving Boyle's law. Alright, so these are the two graphs, and we have another one, which is if we plot graph of pressure times with volume versus volume of pressure, you will get a straight line, which means it's a constant, and you cannot determine what is the slope because the gradient equivalent to 0. Alright, so three graphs. Okay, let's look at the first exercise. Alright, a sample of gas occupies a volume of 10 liters at the pressure of 2 atm. Okay, so we need to highlight what is the given information. Okay, so volume 10 liters at the pressure of 2 atm. Alright, so that is your first one. Alright, so V1 equals to 10 liters and P1 equals to 2 atm. Alright, so the next question, what would be the pressure of the gas if it is allowed to expand in a 50-liter container at the same temperature? So same temperature means we are applying Boyle's law. Okay, so we write down V2 is 50 liter and we are looking for P2. Alright, okay. As I mentioned before, we just need to make sure the unit that we use on the first one should be the same unit that we use on the second. So your volume in the first is in liters. That means your second one should be in liters too. Alright. And your P1 is in atm. That means you will get your pressure, second pressure is in atm as well. Okay. So how to answer this? You need to write down the formula. P1 V1 equals to P2 V2. Okay, so mention here constant N and T. Okay, that is the first mark. Alright. So secondly, you need to substitute the information given into the formula. Alright, so P1 2 atm and then 10 liter. Alright, so P2 and the V2 is 50 liter. I want every one of you to always add unit in the substitution process because I want to make sure you don't get a different unit at the final answer. Alright? Okay, so P2, as we calculate, we will get it is equivalent to 0.4 atm. Okay, so let's check either our answer is correct or not. Okay, so it's correct. Alright, so it's just simple. Okay, let's look for Charles' law. Okay, so Charles' law is what you have done in your last experiment, which is experiment 4. So you carry out an experiment checking on the change in the height of air column when you dip the Charles kit in a different set of temperature of water. So we already done with 4 different sets, which is the first one in a warm water, secondly in the room temperature, thirdly in the cold water, which is we add on ice, and lastly when we mix ice with methanol. Alright, so you have done all the experiment, and we also already plot a graph to show the Charles' law relationship, which is between volume and temperature. And as we can see, at a constant pressure, volume occupied by a fixed amount of gas is directly proportional to its absolute temperature. Okay, so V is directly proportional with temperature. Okay, so these are the formula that we're going to use for Charles' law. And just a reminder, so every time you need to use temperature in 5.1, which is gas, under gas, all the temperature must be converted into Kelvin. So how to convert from Celsius to Kelvin? You just need to add on your temperature in Celsius with 273.15. What is 273.15? This is the value of absolute zero. Alright, so let's look on the graphs that involving your Charles' law. So these are the two graphs. Okay, the first one is graph of V versus temperature, volume versus temperature, and the second one is still the same, but from the second graph, actually we're using this Charles' law to determine what is the value of absolute zero. Alright, so you already plot the same type of graph in your experiment. Okay, so the value of absolute zero is highly determined by this extrapolation process. Okay, so which extrapolation process will depending on the scale of your graph. So that's why for your experiment 4 last time, Some of you might be able to get the absolute zero to be close to negative 273.15, but some of you only managed to get negative 100, negative 150, and various number that I've seen in your lab report. So all of these are related to your extrapolation process, which depends on the scale of the graph that you choose to plot that graph. Alright, so these are the graphs that involving your Charles law. Okay, so let's try to apply the Charles law formula into this question. Alright, so a sample of gas occupies 100 milliliters at 25 degrees Celsius. So highlight the information. What volume would the gas occupy at 32 degrees Celsius if the pressure remains constant? Alright, so V1 is in 100 milliliters. Okay, T1 equals to 25 degrees C, which you need to convert it into Kelvin, which how? You just need to add on 25 with 273.50, which is equivalent to 98.15 Kelvin. Okay, so V2 is what the question is looking for, and your T2 is 32 degrees Celsius. So convert it to Kelvin again, we add in with 273.15. You will get your T2 in Kelvin is equivalent to 305.5 K. Okay. Then we're going to substitute into the formula for your Charles law, which is V1 over T1 equals to V2 over T2. Alright, and again we need to write down what is being fixed or being kept constant, which is constant pressure and number of mole. Okay, so as we substitute, so V is 100 milliliters. Always include unit in your substitution process. 298.15 Kelvin equivalent to V2 unknown. We're going to determine through the calculation, and your T2 is 305.15 Kelvin. Alright, so rearrangement process involved, and lastly you will get the value for your volume. Since we use your V1 in milliliters, that means your V2 answer should be in milliliters as well. Okay, if you calculate, you will get your V2 to be 102.34 milliliters. Alright, okay. Now let's look at the third gas law, which is your Avogadro's law. Okay, so according to your Avogadro's law, at constant pressure and temperature, the volume of gas is directly proportional to the number of moles of the gas present. Alright, so V is directly proportional with N at fixed pressure and temperature. So these are the equation for your Avogadro's law. Again, alright, so your V1 or V2 can be in any unit for volume, which is either milliliter, liter, cm cube or dm cube, okay, or anything else, provided you need to make sure the unit that you use for V1 must be the same unit that you use for V2. And N1, N2 is just the number of mole, which is in mole. Okay, so these are the graph for Avogadro's law, which volume is directly proportional to number of mole. So that's why you just see a straight line here. Alright, so these are the summaries of the gas law that we already learned for today, which is your Boyle's law, Charles law, and Avogadro's law. Okay, so the first row is the definition for your Boyle's law, Charles law, and Avogadro's law, and the second row is referring to the variables that being kept constant, okay, for that law, and the third row is referring to the formula for your gas law. So all of this you need to memorize and apply whenever it's needed.